Okay, how about this question? We have basically a sequence of steps, A, B, C, D, which eventually leads to finding what the derivative is. Uh, you don't have to break them all down into every one of these steps, but if the question asks that, I guess you kind of have to. The first thing I would like to notice is that this function is kind of written in a way that's not as nice as it could be. Because why don't we just rewrite it as like we can put the power of 5 onto each of those individually, like that. And if you work out negative 3 to the power of 5, you get negative 243. So we have this. And why don't I just put the negative on the top? So this is the version of the formula that I'm going to work with. Now, let's take a look at the very first thing we have to do here. We have to find f of x plus h, right? So let's see what we have here. So for part A, what is f of x plus h? Well, since we just replaced this x by x plus h, and that's pretty much all there is to it. But we do have an issue here. I think eventually we're going to have to expand x plus h to the power of 5. I'm not sure if we should do it now or later. Why don't we do it later? So let's see what part B would be this then, right? Whoops. So f of x plus h was done in the previous step. It's just equal to this, right? Minus what f of x is, which is whatever it's right here, right? Negative 1 2 over 243 x to the 5. And I don't know, not too much simplifying we can do there. Why don't we multiply these two so we get negative 243 x to the 5. Actually, you know what? I'm going to factor out the negative 1 over 243. And that way it's that annoying constant is just brought to the front. And this would leave me with a minus 1 over x to the 5, right? And I could get a common denominator here. It'd be x to the 5 minus x plus h to the 5 over the product of those two. And I'll write the x to the 5 first. Okay, I'm kind of tempted to multiply this negative 1 in here, and that'll have the effect of reversing the two terms in the numerator. So we'd have x plus h to the 5 minus x to the 5, and the bottom is still the same. I sure hope you don't think you can cancel these two off or something, right? Or cancel these off. That's not valid. So here's now maybe where we need to do a little bit of work. We have to remember, how do we expand x plus h to the 5? This is really a little lesson, a little review on the Pascal's triangle and the binomial theorem, right? Do you remember Pascal's triangle? Like you start at 1, and then if you're on the edge, to get to the next number, it's just a 1 above it. Same thing here. But if you're in the middle somewhere, to get the number, you add up the two numbers to the left and to the right above it. So 1 plus 1 is 2, right? So again, if you're on the edge, like here, there's always 1s on the edge. And if you're somewhere in the inner part of it, you look to the above left and above right and add those up to get those numbers. And you can carry this out as much as you want. It's called Pascal's triangle. And I'm going to stop here because this is the row I'm interested in. Now, what is the meaning of this? Well, why don't we take a look at this second row? If you remember, x plus y squared is 1x squared plus 2xy plus 1y squared. And you see there we have 1, 2, 1, right? How about we look at this third row? That has to do with x plus y cubed. So it'd be 1x cubed plus 3 x squared. Notice the power of x continually falls and the power of y continually grows. So this is like y to the 0 here. The next one would be y to the 1. The next term here is 3x to the power of 1 less than it was, so it's now to the power of 1. And the power of y is growing, so it's the power of 2 now. And plus 1x to the power of 0 now. And x to the 0 is just 1, so it's kind of just gone. And then it's y cubed, right? Can I skip x plus y to the 4 and go right to x plus y to the 5? It would be, I'm using these numbers now, okay? So it would be 1, which I won't bother writing, 1 x to the 5, y to the 0, which is not needed to be written down. And then here's my 5. The power of x goes down by 1, the power of y rises by 1. And then I just keep following that pattern, right? And I keep looking at my numbers here. So I hope you see what I'm doing here. And I end up with 1, x to the 0, y to the 5. And that's just the same as y to the 5. So we have, we've just expanded x plus y to the 5. I guess back here, though, we're actually supposed to do x plus h, right? But that's no big deal. The concept is the same. Now, what I'm going to do here is the top, x plus h to the 5, I am going to expand that. But the bottom one, I am not going to. I'm going to leave that alone. Now, I'm going to be running out of room here. So what I'm going to do is I'm just going to erase what I've written down. I hope you understood that. Really, that's a review of the binomial theorem, and that's something you should actually already know. It's let's see what we got here. Why don't I... It may look a little bit ugly, but I'm going to go over here and continue because I'm going to need a lot of room. So the bottom, I'm just going to leave the way it was. But the top, I need to expand it out. Let's see. Okay, so do you remember what were those numbers again? It's right here, right? So x plus h to the 5 is basically the same as x plus y to the 5, right? Except for y, I'm just going to put in h. So let's see what we got here. We got x to the 5 plus 5 x to the 4 h plus 10 x cubed h squared, 10 x squared h cubed plus 5 x h to the 4 plus h to the 5. Okay? And now I can get rid of this here. So, but I still, and don't forget this minus x to the 5, right? Remember, all of this stuff here just represents x plus h to the 5. And then I still have to write minus x to the 5. Now, as usual, we hope for some canceling, right? And we do get it. These two cancel. And why don't I... And by the way, notice that in every term that remains, there's an h in it. Let's factor that to the very front, and we'll just put it h over 243. And all of this stuff here, just, well, actually, since I factored out an h, that h is going to be gone, right? And I have 10 x cubed h. Notice the power of h went from 2 and now it's a 1. That's because I took out one copy of h, right? And similarly for the rest of them. Now that's a square, and that's a cube, and that's h to the 4. And the denominator just stays as it was. And I think that's a good answer for part C, or for part B. Let's now do part C. Remember what that was? It was to the one we this big complicated expression up here is just f of x plus h minus f of x. And now we have to put that over h, right? So we're basically dividing this thing by h. And don't want to write it all down again. So I'm just going to copy it. And I don't even have room. Just give me 1 second here. So we can make that work. And why don't I put the equal sign here? Now, that's just the numerator, right? I still have to, excuse me. I still have to put that all over h, right? I know it looks pretty nasty, but... And you know, this h and this h cancel. So I'm left with 1 over 243 times all of this stuff here, right? And I need more space, I guess. It's nice not having to recopy all that. That's the answer for part C, okay? So I divided by h, and now I'm ready to actually do that derivative, right? The limit as h goes to 0 of all of this stuff. And this limit is, well, I guess I'll cheat again and recopy all this. So really what this is, I just have to put a limit sign in front of this expression and I'll be on my way. So here's the thing we have to evaluate, and we're finally reaching the end here. And the nice thing is, since h that was on the denominator has now canceled off, we can just put h equals 0 right in, right? So let's see what happens. We have 5x to the 4. And you know, all these other terms have an h in it, right? So we're just going to have zeros for all those. And the bottom is x to the 5. And it's x plus 0 to the 5, right? And notice I stopped writing the limit sign as well. And what does this give us? The top is, of course, just 5x to the 4. What about the bottom? Well, x plus 0 is x. X to the 5 times another x to the 5 is x to the 10. So it looks like that. Those powers of x can be subtracted. Well, why don't I also put the 5 over here? And we get times 1 over x to the 6, right? Which I guess we could write as 5 over 243 x to the 6. And that was a little bit long, but that is the answer. And that makes you appreciate the rules for derivatives, right? Because if you have the rules for derivatives, you can do this question really quickly. Remember our function, we simplified to this, right? What I would do if I was allowed to use the rules of derivatives, I'd write it like this. And then I'd use my my power rule. So it would be negative 5x to the power of negative 5 minus 1, which is negative 6. And we actually get the same thing as we just figured out, which took us many, many steps. Negative 1 times negative 5 is positive 5. And x to the minus 6 up there can be brought down to x to the 6 down there. And we get the same thing as before. So if the question asks, though, to use the definition of the derivative, this is not an option. But if you are allowed to use the rules of derivatives, it's definitely much nicer to do it like this. Okay, so that's the end of that one.